So operation amplifier as integrator. This is the circuit diagram of operation amplifier. This is an integrator. So this is inverting terminal, this is non-inverting terminal, this is output voltage. So this is input capacitor connected to the inverting terminal. The signal is connected to inverting terminal through signal. This is input Vn. So the current flowing through resistor is In. So the non-inverting terminal is connected to ground. So the feedback capacitor is connected across a inverting terminal and output voltage terminal. So let the voltage at this point is VA. So apply KCL at this point. So the current is coming In. So current is leaving this point Iz. So current is leaving If. So according to Kirchhoff's current law, the algebraic sum of entering currents and leaving currents is 0. So the entering currents is taken as positive and leaving current is taken as negative. So apply KCL. Apply KCL at VA point. So in current, so In is entering this junction, so plus In input. So Iz is leaving, so If is also leaving. So according to virtual ground, Iz is equal to 0. Therefore In equal to If. In equal to If. We have to find the current across this resistor and the current across this capacitance. So for example, the current across input resistor we have to find. So this is input resistor and this point is Vin and this point is VA. So therefore In equal to Vin minus Va by Rn. So like this we have to find we also substitute these values in this equation. Therefore Vin minus Va by Rn equal to If. So we have to find feedback current. So the current across a capacitor C. So Q equal to CV. We have to find voltage across this capacitor. So Q equal to CV. Q is the charge. C is capacitance. So V is voltage. So I is equal to dq by dt. I equal to rate of change of current with respect to time. So here Q equal to CV. dCV by dt. So C is the constant. So therefore dV by dt. So I equal to C dV by dt. So the voltage across a capacitor is C dV by dt. So C dV by dt. We have to find voltage across this capacitor. So let's CF. this point is VA and this point is V0. So current is flowing like this. So IF equal to C D VA minus V0 by dt. See, so according to virtual ground, V equal to 0 minus V0 by dt. So therefore, IF equal to C D minus dV0 by dt. So we find voltage across a substitute IF value in this. So minus C dV0 by dt, dV0 by dt. So according to virtual ground, V equal to 0, V in minus V in by R in equal to minus C dV0 by dt. So integrate on both sides. Integrate on both sides. So transpose. So V in, take this into this side dt. Take this into this side minus of R in C dV0. So integration, differentiation cancel. Therefore minus R in C V0. So integral of V in dt. So take this R and C into this side. Therefore minus 1 by R and C integral of V in dt equal to V0. So this is the formula, this is the derivation for, therefore V0 equal to minus 1 by R in C integral of V in dt.